Hey guys, so these are the notes for dilations. So by the end of this video, you'll be able to draw new figures and dilate them on the coordinate plane and find their scale factor. So to go through the notes on this, we have to remember that a dilation is a change in size. So it could either get bigger or it could get smaller. Okay? Now, it's a change in size given a scale factor. A scale factor is that ratio, it's a fraction of how much bigger or smaller is the object. Now to find the scale factor, we use the fraction image over pre-image. And if you remember those terms, the image is the after over the before. So then we reduce that fraction down, and that is our scale factor. So there are two types of dilations. There's an enlargement and there's a reduction. An enlargement is when the figure gets bigger. So from the orange to the green, it got bigger. It means the scale factor is going to be larger than 1. A reduction is when a figure gets smaller. So from the orange to the green. That means the scale factor is going to be less than 1. It's going to be a fraction or a decimal. All right. So when we're doing it on the coordinate plane, to do an enlargement or a reduction, all we do is we multiply the coordinates by the scale factor. Okay? So if a scale factor is 2, we would multiply all the coordinates by 2. For a reduction, sometimes you're given a fraction, like 1/2 or 1/3, or sometimes you're given a decimal. So there's two ways of doing it. You can either divide the coordinates by the denominator, the bottom number of the fraction, to make the figure smaller, or you can multiply by the decimal. So, 1/2, if it's 0.5, you can multiply the coordinates by 0.5. So that is how you do this on the coordinate plane. Now, for examples on this, okay, first thing we have to figure out is the scale factor. Okay. So we have to figure out, okay, what's the first figure, what's the second figure? Okay, the first figure is P, the second figure is P apostrophe, remember, okay? So, first off, we're talking about this figure right here, this triangle, and this triangle here. Well, we can tell that's an enlargement. Okay, because the figure's getting bigger. And the scale factor is going to be the image over the pre-image. Okay, the before or the after over the before. So the distance from C, that point, to my image is 10 over 7. That is my scale factor. Okay, while in here in example B, my first image is this big square. My second image is this smaller square. So it's a reduction. Okay? So then I would say, okay, what's the image? Okay, that's 2 over 6. Well, 2 over 6, we don't leave fractions like that. We always have to reduce fractions. So this is going to reduce down to 1/3. And that's how I find the scale factor and determine if it's a reduction or an enlargement. If you notice, the numerator here, the 10 divided by 7, that's going to be greater than 1. While the 1 divided by 3, that's going to be a decimal, 0.3333. That's going to be less than 1. Okay. So, our next step are these types of things. All right, where we're reducing fractions, we're setting it up. Are we reducing? Are we enlarging? That sort of thing. So again, we look at the letters, okay, and whichever has the apostrophe is the image, is the second figure, okay. So the second figure is smaller, so it's a reduction, okay, and it's a reduction. Well, if I do 6 over 14, that's going to reduce down. They're both divisible by 3. That's 3 over 7. That is my scale factor. and I could have also done it with this 3 and the 7. You'll notice that the scale factor is always the same. While in problem number 2, there's a little trick to it. This is my first and this is my second. Well, how far is it from C to go here? Well, it's 15 to here, 15 here, that's 30. Okay, so this is going to be 30 over 15. The image over the pre-image, which this is going to reduce down to 2 over 1, or just 2. You can write it just as 2. Now, because this is greater than 1, this is an enlargement. Okay. So you're going to follow these same procedures for these two. On the coordinate plane, again, you're given the coordinates. So the first thing you're going to do is you're going to graph your first. Okay. So -2, -2. There's my A. 1, -1. B, 0, 2, C. So there is my first figure. Now it says, find the image of this triangle after a dilation centered at the origin. Again, they're going to be centered at the origin. With a scale factor of 2. Okay, so the scale factor of 2, this is an enlargement. So all I do with these coordinates, okay, so if A is -2, -2, the scale factor tells me, okay, I'm going to take 2, and I'm just going to multiply both of these by 2 to create a new one. So if I multiply these by 2, my new A apostrophe is now -4, -4. Okay, my B was 1, -1. So now I multiply by 2, that scale factor, and my new B apostrophe is 2, -2. And I can do the same thing with C, 0, 2. I multiply by 2, C apostrophe becomes 0, 4. Now if I plot this, 0, 4, that's my C, -4, 4, that's my A. And -2, 2. Or 2, -2. That's my B apostrophe. You see how the figure got twice as big. Now, that is an enlargement. For a reduction, we're given, okay, now this is 0.5. 0.5 is a less than 1, so this is a reduction. So what I'm going to do is I'm going to take each one of these points, I'm going to plot them. I'll plot them in blue. 2, 4, and 2, -2. Now it's a reduction by 0.5. So because this is a decimal, I can just take each one of these coordinates, like E, -2, -2, and all I'm going to do is multiply by 0.5, because I multiply by the decimal, which comes out to be my new E prime, which is -1, -1. So that is -1, -1. Boom. Okay, now I would repeat the same process with F, -2, 4. I multiply by 0.5. And my new F prime is going to be -1, 2. -1, 2. I can repeat each one of these and get my new G is going to be 1, 2. And my H is going to be 1, -1. And when I plot them, it becomes a smaller rectangle in between. So all I'm doing is multiplying by that decimal. So that's always something that you can do to dilate the figure. I'm going to leave 3 for you to do. Again, R is the scale factor, so it's a scale factor of 2, so it's just like example number 1. I want to give you another example of a reduction, and that is number 2. So this is where I give you a scale factor of 1/3. 1/3 is a fraction. Now I can always divide that and get a decimal and work with the decimal. But when you're dealing with thirds, it doesn't come out that nice. So what I do is I can divide by the denominator. So I look at 1/3. Well, 1/3 is really the same as dividing by 3. So I'm going to take each one of these points, A, 0, 0, and this isn't a good example, okay? And I'm going to divide by 3. And this is when you have a fraction, okay? You can always divide by the numerator, or the denominator, all right? So my new A apostrophe, okay, is 0, 0. That didn't change because I'm dividing, or 0 divided by anything is 0. My new B, 3, 3, I divide by 3, it becomes 1, 1. Okay? My C, 6, 3, when I divide by 3, becomes 2, 1. Okay? And I would just continue doing this until I generate this list. Again, when you're given a fraction, I can just divide by that denominator, and I create that new figure, and it's a reduction. Now, you might not see there is a green figure and an orange figure inside here. Now, we can also look at this as r is 2.5. Now, you might say, oh, it's a decimal, this is a reduction. This is not a decimal, okay? When I said a reduction has a scale factor that is less than 1. 2.5 is greater than 1, so this is technically an enlargement. And all I do is I take 2.5 and I multiply each one of these coordinates, and I create a new triangle that is going to be bigger, okay? So I'll give you the picture of it. It's going to look like this. Okay, and you're going to have to estimate. But I want you guys to find the new coordinates for practice. That is how you do a dilation on the coordinate plane and find the scale factor. So please complete the rest of these practice problems. Come to me with any questions, and then check your answers. Thank you very much.